Okay, we're going to learn a third form of linear equations today. It's called point-slope form. So the first thing I want you to do is just try this. A line goes through the point 2, 5 and an unknown point x, y. Its slope is 3. I want you to try to set up a true equation based on these facts. Okay, so try to do that without me, and then I'm going to go ahead and do that too. So what I know about slope is it's rise over run, or y2 minus y1 over x sub 2 minus x sub 1. Okay, so what I'm going to do is I know that the slope is 3, and I know that to get 3, I'm going to do the second y, which is y in this case, minus 5, because that's my first y, over the second x, which is x, minus the first x, which is 2. And I know that slope has to equal 3. Okay. 1 minus 5 over x minus 2 equals 3. Okay, so if you wrote that, that's awesome. That's what I would like you to do. What I want you to notice on this problem is that we can rewrite this by multiplying both sides by the denominator here. If I don't want to have any fractions in my final answer, that would be something I'd be allowed to do. So I could multiply both sides by x minus 2 if I wanted to. The good thing about that, these would cancel out. I'd have no more fractions in my answer. Another way I could write that is y minus 5 equals 3 times the quantity x minus 2. Okay. This form that I've written in it right here, this is called point-slope form. So definitely write this down. The point-slope form of the equation of a non-vertical line that passes through the point x sub 1, y sub 1, and has slope m can be written like this. Y minus y sub 1 equals m times the quantity x minus x sub 1. Okay, we're going to use that for quite a few things. Okay, so we're going to use the definition of slope this time, the slope formula, to write an equation in point-slope form for a line that passes through 3, 7 and has a slope of 4. So there are two ways that I can approach this problem. One, I could know that it will always go through the point x, y, if x and y are variables. So I could just do the same thing that I did the first time, saying, okay, well, its slope is y minus 7 over x minus 3, and that must equal 4. So I'm going to go ahead and I'm going to multiply both sides by x minus 3 to get rid of that on the bottom. And lo and behold, y minus 7 equals 4 times the quantity x minus 3. That's in point-slope form because it looks like this. Y minus y sub 1 equals m, which is the slope, times x minus x sub 1. Okay, another way that I could have done that same thing is just go straight from the formula. To do that, all I would do is replace the things with what I know. So this is my x sub 1, y sub 1, because that's my first point. So I do y minus 7 equals m, which is my slope, 4, times x minus my x sub 1, which is 3. Okay, this is point-slope form. It matches what I did by doing it the other way. Choose the method that you like better. Okay, so sometimes an equation is given in point-slope form, and I would like you to graph it straight from it. You could transfer this to a different form, like slope-intercept or standard if you wanted to graph it that way. But it's nice if you can graph straight from it. It makes it convenient. So if I'm graphing straight from it, I still want to know my formula because that helps me identify key information. So the first thing I like to notice is what's my slope? Hey, there it is. My slope in this equation is 1/3. The second thing I like to notice is what point does it go through? So x minus x sub 1, y minus y sub 1. So x minus 1, that means 1 is my x coordinate. Y minus 2, that means 2 is my y coordinate. So it goes through the point 1, 2. So to graph an equation like this, the first thing you'd want to do is start at the point 1, 2 and graph it. And then use the slope 1/3 so that, remember, I'm going to rise 1, run 3. Or I could do it the other way, like down 1 over 3 this way. Okay, I've graphed my equation, and I've done it by finding that it goes through the point 1, 2 and locating the slope of 1/3. Okay. All right. I would like you to try this one on your own and then come and check if you're right. Okay. So again, I want you to write it in point slope form unless I specify otherwise. So all I'm going to do in this case, y minus y sub 1, and y sub 1, that's here. Okay, that's my first y. So y minus negative 3. I probably won't write minus a negative. I will probably change that to plus 3 equals slope m, negative 2, times the quantity x minus x sub 1, and x sub 1 is positive 3 in this case. So that's my equation. It's in point slope form right now. Okay. All right. This time what I'd like you to do is try to write an equation for the line in point slope form and slope intercept form. So you can pick either one, whichever to start out with, but because the y-intercept's not at a whole number here, I think it might be a little bit tricky to do. So I'm going to try point slope form first. So I'm going to use figure out my slope. It looks like it's going down 1 and over 3. So my slope is negative 1/3. And then I can use either point to be my x sub 1, y sub 1. It really doesn't matter which one I pick. I'll pick negative 1, 4 just because it's on the left. So I'm going to do y minus 4, that's my y sub 1, equals slope, which is negative 1/3, times x minus negative 1. So I'm just going to make that x plus 1. Okay, so this is point slope form. To get it to slope intercept form, in my opinion, the easiest way is just to y, which is y equals mx plus b, is to just solve this equation for y. So I would go ahead and I would start distributing and doing the things I know how to do. So I know that y minus 4 equals negative 1/3 x plus negative 1/3, or just minus 1/3. That's not in slope intercept form yet because I have an extra number with y. So I'm going to add 4 to each side. And then it looks like y equals negative 1/3 x plus 3 2/3. So this is slope intercept form. And if I look to see if that makes sense, it looks like right there, my y-intercept looks very close to 3 2/3. That seems very logical. So I would recommend that you start out with point slope form and then transfer it to slope intercept form. Okay, you guys, this whole unit's on writing linear equations, or just linear equations in general, and you know that that means that it has a straight line on a graph or a constant rate in a table. So if the rate of change between consecutive pairs of data is always the same, that's going to be linear. We're going to look at a couple tables now, and your job is to figure out, one, is the relationship shown by the data linear? And if it is, I want you to model it with an equation. So here's my first data pair, or my first table. So if I'm looking at it, first I want to check, does this have a constant rate? So it looks like here it's going down 2 and up 1. Here it looks like it's going down 6 and, and down 1. Down 6 and down 3. And here it looks like it's going down 4 and down 2. So it's skipping around a little bit, but if I look for the rate of change, remember that's rise over run, or change in y over change in x. So here, negative 2 divided by negative 1, that's 2. Negative 6 divided by negative 3, that's also 2. Negative 4 divided by negative 2, that's also 2. So yes, it looks like it's linear. They all have the same rate of change. And I'm going to write an equation. So I know my rate of change, or my slope, is 2. If I want to write an equation, it is by far the easiest to write it in point slope form if you can memorize point slope form. So pick any point you want. I'm just going to pick this first point. My equation could be y minus 6 equals slope, which is 2, times x minus 3. Unless I tell you otherwise to write it in another form, you could be done. Okay, so I might want you to write in slope intercept or standard or something, but if I just say write an equation, you can pick whatever form you want, and that would be a totally acceptable form. Okay, all right, try this one for me. Do that one on your own, and then come back and have me check it. Or check it by what I'm saying on the video, I guess. So here again, I'm going to look at rate of change. So this looks like it goes up 1 and up 1. This looks like it goes up 1, but up 2. So already I can see that 1 over 1 equals 1 and 1 over 2 is 1/2, 0.5. It does not have a constant rate of change, so this is not linear. Okay, there may be some equation that I could use to write it, but I don't have to write it because it asks me to only write for linear equations. Okay, so I want you to look at these 3 forms of linear equations. It would be very, very worth your while to memorize the information on this table, that you know what each form is and the key parts about it. So slope-intercept form, that's y equals mx plus b. You should definitely have that memorized. The m is the slope, b is the y-intercept. Practice, practice. Standard forms when ax plus by equals c, a and b are not both 0. And remember, that's candy for finding the x and y-intercept. Point slope form, it's y minus y sub 1. Parentheses are optional on the y side. Equals m times the quantity x minus x sub 1. And things to know, x sub 1, y sub 1, that's a point on the line. It lies on the graph of the equation. M is the slope. You should know those things about your linear equations. I would try my best to memorize those if I were you. So yeah, teacher says this is important. Here are what I want to leave you with to think about. So tell your partner, which could be your laptop, which form of linear equations you like best and why. And then I want you, this is homework right here. Try to come up with at least 2 cases in which each of the 3 forms would be the most useful or convenient. So why might each one come in handy? What would they be good for? Try to come up with at least 2. Write this down. Bring your answers into class tomorrow because I would like to discuss this and I want to see if you can come up with everything, the best uses for every case and why we like to have more than one form. All right, food for thought. Come in tomorrow with that done, please, and have a lovely evening.